Okay, thanks to everyone who stayed around and not gone downtown. I promised to finish by 8 o'clock, if not before, and then we can line up and race for the cafeteria. I'm going to tell you a story, and it's sort of an old story. It's something that happened to me 30 years ago. My excuse for doing it is I think it's an interesting story. At least it's more interesting than anything I've done since then. And it shows how sometimes epidemiology can answer questions which other approaches can't answer. But also it shows that there's not one study, or not just epidemiology alone. It's a bunch of different types of studies and different types of research that helps you answer questions. So this story started for me actually 30 years ago, more or less this month. I was sitting in my office in Wellington in New Zealand, not doing anyone any harm, and this guy came to see me and started talking about an epidemic of asthma deaths in New Zealand, and a drug called phenotyrol, which I'd never heard of. And I sort of vaguely knew about asthma, though I got it confused with eczema. I didn't really know much about it. But, you know, it sounded like it was worth a look. So I thought I'd start by reviewing some of the history and some of the literature of this issue. And it turned out it was a problem that had been around for a while. There's only a few countries have good asthma deaths data going back a very long time. In the UK, they have it back to 1900. And what you see is that certainly for the UK, asthma mortality was very low for more than 80 years. And then in the 1960s, there were these sudden epidemics of asthma deaths that occurred in half a dozen countries. New Zealand in red, Australia in green, England and Wales in black, also Scotland, Ireland, and there was one of the Scandinavian countries, either Norway or Sweden. I think it was Norway, I might be wrong. And those were totally out of the blue. You know, if you looked at the previous 80 years or so, it was just dead flat, and then suddenly they happened. But nothing in West Germany, nothing in Canada, and nothing in the US. And there was a lot of alarm about it at the time, and there were studies of it in the 1960s, particularly by Richard Dole in Oxford and other people. And what could account for an epidemic? It could be that the disease had suddenly got more common, but there was no evidence for that, and why would that suddenly happen in Norway and not in Sweden, or the other way around? It's more likely that the case fatality had gone up. And once again, that might be increased severity, but there was no evidence that was happening, and it just didn't seem sensible it would happen in some countries and not in others. Could be environmental factors, but once again, there was no, it's not like air pollution had suddenly doubled overnight in some countries and not in others. So the most likely explanation was that it was some change in medical management, because that's something that could happen suddenly and could happen in some countries and not in others. And the most likely thing is a new drug. And it was just then that the inhalers were coming in. So those of you who have asthma, you probably use an inhaler, and it was in the early 1960s they suddenly became available, and they're really convenient, so the sales took off around the world. And in the England and Wales, the inhalers were available for sale over the counter. You could just go and buy one at the chemist, at the pharmacy. And you can see they first came in 1961, and these are the sales going up. This is the death rate. By about 1966, they realised that something was happening, and warnings were issued about overuse of these inhalers, and also they were removed from over the counter, so you had to get a prescription. And the sales came down, and the death rate came down. And incidentally, this has never been proven, but for those of you that are interested in music history, Brian Jones from the Rolling Stones was a severe asthmatic and died at this time. So it's probably affected music history as well, but who knows. So this is a paper from The Lancet in 1969. The excess deaths were likely to have been the result of excess use of pressurised aerosols. The subsequent decline in mortality resulted from a greater awareness by doctors and patients of the dangers of overuse. No one ever did a case control study. It sort of seemed clear, at least in the UK, that the time trends alone explained what had happened. Richard Dole and others were involved in studying it. But there was a guy called Paul Stolley, who was American, who was on sabbatical in Oxford, and Richard Dole was talking about this problem and said, well, I don't understand why there's been no epidemic in the US of asthma deaths, but probably doctors are more careful there, and Paul knew that wasn't true. So he thought probably Dole and the others had got it wrong. And he was thinking of whether to spend some time for a sabbatical on this, and he was staying in a little village outside of Oxford. Didn't get to know the neighbours very well, but they knew he was a doctor. And one of on a Sunday, the neighbours came to him because the guy in the neighbouring house, he had severe asthma, and it had been so bad that he had his wheezing during the sermon, and so he'd gone home. And later on, they checked his room and found him dead, holding the inhaler. So Paul thought, well, maybe there's something in this, but he still thought, it couldn't be true because of the time trends. And what he did was get all the drug sales data and all the asthma mortality data from as many countries as he could. And he found something very striking, which no one had ever noticed before. See, at the time, the only beta agonist, or almost the only beta agonist available, was called isoprenaline. These things are complicated because they have generic names and brand names, and the generic name is supposed to be the same universally, except the US has different versions, and then the brand names are different in almost every country. But isoprenaline was the main, or virtually the only beta agonist inhaler, and there was a forte version. There was a strong version, which was only available in 8 countries, and 6 of those were the countries that had the epidemics. And 2 of them, it was available, but the sales were very low and it was introduced very late, by which time they already had warnings. So if you looked at the total sales of beta agonist inhalers, it didn't seem to fit, but if you looked at the forte version, then it actually fitted very well with the epidemic, with the 6 epidemics. And what was very unusual about it is normally the forte version might be 50% or maybe double the dose of the regular one. This was 5 times. It's very, very unusual, and it's still not clear why it was marketed in such a high dose. So there was something very unusual with the forte inhaler. And also, at the same time, there actually was animal evidence. What these drugs do, if you've got something like salbutamol, Ventolin now relieves the symptoms, it relaxes the muscle in the airways, so that's a beta-2 effect. All these drugs also have a beta-1 effect, which is on the heart. They make your blood pressure go up, and they make your heart race a little bit. And particularly the early versions were quite bad for that. And what they showed in dogs is that you could give a dog a massive dose of these drugs, and it would have tachycardia, or its heart would race. Its blood pressure would go up, but it was almost impossible to kill the dog unless you made it hypoxic. If you made it short of oxygen, which is exactly what happens in an asthma attack, it would kill the dog almost every time. And they wouldn't get arrhythmias, they'd get a tachycardia, the heart would race, they'd get bradycardia, it would slow down, and they'd die of asystole, and with massive heart damage. And what's ironic is that probably these drugs are completely safe if you don't have asthma, but if you're hypoxic and you're having an asthma attack, it's a different story. And what was observed at the time was that the people who died in the epidemic, 95% of them never made it to hospital. And if they made it to hospital, they almost always survived. Now, what the clinicians were saying at the time is, we give patients massive doses of these drugs and they never see a problem, because if you go into hospital with an asthma attack, the first thing they give you is oxygen. and then the drug's completely safe. So there was actually pretty good evidence about what was involved. And I got involved in 1988 and read a few of these things, and particularly there was an editorial in the British Medical Journal in 1972 which reviewed the work of Stolley and the dog work, I think, and said this strengthens still further the case for relating the increase in asthma deaths to this is beta agonist drugs. The dose should not be increased in the absence of a normal response. So that was the opinion at the time. And virtually the next thing I read, this is from a free journal that goes to doctors in Australasia, 1988. There is no such thing as overuse of beta agonists. These drugs should never be withheld for fear of toxicity. Use of beta agonists does not seem to be an important factor in deaths from asthma. So naturally I thought, well, you know, what happened in the 16 years in between? What new research was there? And the answer was nothing. There was no new research. What you had was a series of reviews, some of them funded by particular drug companies, that firstly raised some anomalies with the 1960s data, and then those minor anomalies became major problems and they became fatal flaws, and the whole story got rewritten. So I talked to clinicians in 1988 and they'd sort of say, well, people thought back in the 1960s these drugs were causing deaths, but that was all proven wrong. And if you'd asked them how it was proven wrong, they wouldn't know. It was just sort of known that they were proven wrong. So that was the state in 1988. So this is New Zealand. This is isoprenaline forte, the drug that caused the 60s problems. Sales going up, warnings issued, sales came down. This is the death rate. And then in 1976, New Zealand had a second epidemic all of its own. There was no epidemic anywhere else in the world. And naturally there was some people said, well, it was caused by drugs in the 60s, so it might be again. And the clinicians were very like, you know, we've spent 15 years proving that it wasn't due to drugs. We don't want to raise this all over again. Our patients will get concerned and so on. And so there was real resistance to any suggestion that it might be due to drugs. And there was an asthma task force of several senior people, including the dean of the medical school I worked in, who got a lot of funding from the Medical Research Council in New Zealand and spent 10, 12 years studying the epidemic. Never did a proper study because they didn't really understand epidemiology, but had lots of case reports and just concluded that clearly it was not due to drugs. So they concluded that excessive use of bronchodilator drugs did not account for the high mortality rates. Some of the papers said that maybe it was excess reliance because there was one epidemiologist involved who occasionally tried to, you know, keep touch with reality. But to the extent that bronchodilator treatment might be responsible, the idea was more that just they relieve your symptoms so you delay going to hospital. So it's like the patient's fault. They haven't gone early enough. And it is true that if you read the reports of the deaths in the epidemic, almost always if people would set off for hospital half an hour earlier, they probably would have survived. So there is a delay problem. But also, it was true that the data didn't seem to fit. This is sales of beta agonists in New Zealand, and this is the epidemic. And you can see the sales actually started to increase later. They increased after about 1979, and that was because there was a worldwide, or at least Western world, change to no longer using the beta agonist as required, but to take it 4 times a day. And there was no good evidence for it. It was just one of these influential committees decided it was probably a good thing, probably because athletes take it before they exercise, so maybe if you took it all the time, it might prevent attacks. And so the sales, you know, were increased by a massive amount in Western Europe and North America. But it didn't fit. And everyone knew that isoprenaline was a bad drug, probably, but that was gone. We had this new generation of beta agonists. And the sales data just didn't fit with the death data. And also, it was sometimes said that, you know, the problem was people not taking their inhaled steroids. For those of you who don't know about asthma, the reliever drug, the beta agonist, relieves the symptoms, but doesn't cure the underlying problem of inflammation. That's what the inhaled steroid does. So in English countries, for example, you'd have the blue inhaler to relieve symptoms and the brown inhaler to take regularly to deal with the inflammation. But this didn't fit, and actually New Zealand by this time had the highest use of inhaled steroids in the world, and didn't fit at all with the death rate. People said that asthma must just be more common in New Zealand, but we subsequently proved that wasn't true. It's high, but it's the same as the UK and the US and so on. And that's probably the way it would have stayed if it wasn't for Julian Crane. Now, Julian was the Boehringer Ingelheim research fellow at the medical school, working with the dean, and he was doing various clinical trials and things. But he came over to Europe, and it's a long way. You often catch a cold on the plane. And he went back to New Zealand and had bad cold, and he had severe wheezing for the first time in his life. And he had all these free samples of his funder's products sitting around the office. So he thought he'd try, take a beta agonist. And he got the shakes really badly. And he suddenly realised that his patients had been telling him that for years, but, he'd always say, no, it's not a problem. And in one of those great moments in science, he asked, maybe not all of these drugs are the same. And in fact, there were 3 beta agonists commonly used in New Zealand at the time. Salbutamol, Ventolin, some of you are probably still using that. That was the biggest seller worldwide. Normally terbutaline, which is from Astra, would be the second one, and then the third one would just be 2 or 3% market share. But for various reasons, Boehringer Ingelheim had got very good at marketing phenotyrol Beratec in New Zealand. They had these annual meetings where doctors would get together and talk about respiratory medicine in Rotorua, which is not quite a nice tourist spot, and convert the specialists to using that drug, and then go to the GPs and say the professor has changed his patients to this drug, and so on. So they actually got a 30% market share, which was outside of Germany, where it had a big market share but very low sales because the overall use was very low. This was the only country in the world with such a big market share. And if you looked at phenotyrol, it sort of fitted. The drug came in 76. There's big argument about how to draw these graphs. I draw them as market share because the sales were increasing anyway because more and more mild asthmatics were taking it 4 times a day. Other people would draw the graphs different ways. But this is, I think, the best way to do it. You see the sales go up and plateau. You see the death rate go up and come down a little bit after 81 when there was some warnings, and then sort of bounce around a bit because you're talking about fairly small numbers. 81 was when the epidemic first hit the headlines in New Zealand, and it happened because the Auckland Asthma Society, I think either 2 or 3 members of the committee died, and there was a lot of concern. And there was a paper published at the time which said, well, maybe what's unusual in New Zealand is that they're using the beta agonists together with oral theophylline, which most other countries were not doing, and it raised this hypothesis in the Lancet. The guy who did it subsequently became medical director of Boehringer Ingelheim, which is another complication to the story. But anyway, it was published in the Lancet. Big headlines, a lot of concern, people took a bit more care, but it didn't seem to fit. But Julian went back to the original paper in the Lancet. This was 1988 now, and he went back to the 1981 paper, and the paper never mentioned any of the specific drugs. It was about beta agonists in general because everyone knew they were all the same. But it happened there was a table in the paper which actually listed what drugs people were on, but with no comment. And this was 16 sudden deaths from asthma. 3 of them, they didn't know what drug they were on. The other 13, 10 of them were on phenotyrol at a time when it had a 30% market share. And that had been sitting in the Lancet for 7 years, and no one had ever commented on it. So Julian and the others started doing clinical studies, and by now I was getting involved. These are QS2I or QS21. I think it should be QS2I. But these are measures of the cardiac side effects. And of course, the other thing that's significant here is that when these drugs are tested before they're released, they're tested as required, to use as recommended. So maximum 2 puffs 4 times a day, or maybe 2 puffs when you're having an attack. We did a study of patients coming into hospital with an asthma attack and asked them how much they'd taken. And something like half had taken more than 50 puffs before coming to hospital. There's something psychological about the inhaler. People won't take a whole bottle of pills, but they'll keep puffing on the inhaler. Just one more puff might work. And I got the same story from a friend of a friend who nearly died during the epidemic. You know, basically just kept puffing and it stopped working and then finally set off for hospital. So you can't test them that way, but you can test them, 2 puffs and then 4 puffs and then 8 and so on. So this is placebo, and these are side effects on the heart. They're trivial normally, unless you're hypoxic probably. This is salbutamol, which is the best of the available drugs. You get a bit of an effect, but not too much. This is isoprenaline. You get a big effect, but it's actually short-acting. And so you get these big effects, but quick recovery. Phenoterol was longer acting in terms of the beneficial beta-2 effects on the lung, but also the beta-1 effects were also longer acting, and they accumulate. So by the time you've got up to about 8 puffs, you're actually as bad or worse than isoprenaline, which is the drug that had caused the previous epidemic. And no one had tested it that way before, because that's not the way you recommend to take it. And we did later research showing that actually isoprenaline and phenoterol are fundamentally different drugs. They're full agonists at the beta-1 receptor, which means if you keep taking them, the side effects just keep going up. Whereas ones like salbutamol, they're partial agonists, so they plateau out, and you keep taking it and the side effects will not get any worse. Okay, so we thought we'd better do the case control study that should have been done previously. I should say that almost everything I'm going to talk about here got turned down for funding and got quite a lot of opposition. At the time, I'd just finished my postdoc, but I had a tenured lecturer's position, and I ended up resigning from it and going on short-term funding so I could study this because it was being made so difficult for us. But the first study, applied for funding and got turned down, but found a way to do it anyway. We had the cases because this asthma task force had, for 2 years, had studied every asthma death. They'd reviewed them all individually, and they'd decided that they weren't due to asthma drugs. But we had the medication. Of course, most people didn't make it to hospital, so they had information from the GP. Okay. So we thought about what to compare them to, and the problem is if you take a random sample of asthmatics, most of them are very mild. So you're going to get quite severe confounding by severity. So we thought about it, and there was one previous study which had said that asthmatic patients who are admitted to hospital and those who die appear to come from a similar proportion of the asthmatic population. They're not exactly the same, and obviously one group died and one group didn't, but in terms of chronic severity, it seems that if you end up in hospital and there was some tendency to prescribe some drug to more severe people, then it's at least a more valid comparison compared to people who had very mild asthma. So this was the defect in the study, but there was no other way to do it. The cases, we already had the data from general practitioner questionnaires from the previous mortality survey, which with quite a lot of effort we eventually managed to get access to. And the controls, we just got someone who had been admitted to hospital around the same time, usually on the same day or the same month, and just saw what was their regular medication in the hospital notes. It's obviously a big concern if the data is coming from different sources for the cases and controls, but we did quite a few checks on that. One of them was that we tried restricting the analysis to people who were just on one beta agonist, and basically the findings didn't change. Okay, so that's the basic results. 113 cases, about half on phenoterol and half not. The controls, it's about 40% versus 60%. The odds ratio is 1.6. The salbutamol is virtually the inverse because people are on one or the other mostly. 1.6, some people got excited because it was statistically significant, but it's not that strong given that it wasn't a perfect study and there's lots of potential for confounding by severity. So, you know, I was fairly skeptical. But the next thing is to look at severity, where if you just look at more severe patients, then within that group there should be less confounding by severity than if you look at basically all the deaths. So, and the best marker of severity that's around, and this has been found consistently, is if you've had a hospital admission for asthma in the previous 12 months, you're more severe and you're more likely to die in the next 12 months than someone who hasn't had a hospital admission. So we split the cases and controls into those who had a hospital admission in the previous 12 months and those who hadn't. And what we would have seen if there was confounding by severity, this estimate of 1.6 would have gone down towards 1 in both of those subgroups. But what we found was there was not confounding by severity, there was effect modification by severity. In other words, the more severe people within that group, the phenobarbital relative risk actually went up. So within the most severe asthmatics, those taking phenobarbital were twice as likely to die as those who were taking something else, which was normally salbutamol. The most severe category we could get was if they'd had an admission in the last year and they're on oral steroids, and there were 20 deaths, and 18 were on phenobarbital, and the relative risk was 13. So if what we were seeing was confounding by severity, it would have gone down towards 1 as we had a more and more stricter definition and made comparisons within that subgroup. But it went the other way. So it was this table that convinced me there was something real. Okay, so we gave to the Ministry of Health, who wanted to give it to the company, and we said, oh, we're a bit worried they might influence publication, but eventually we agreed, and the Director General of Health sent it to the company saying, I'm providing this copy of the draft paper on the understanding that it will not seek to influence the normal process of publication. And sent it off. And we got, let me just check this. Okay, so it was being reviewed, and I was over in the UK, and I went to see Richard Dole in Oxford because he'd done the previous work, and I didn't know him very well, but I knew him enough to go and visit him, and had a nice lunch in Green College and so on. And also we'd sent him the paper for comment, and he'd given us comments, and we'd acknowledged him. And he said, oh, I've just got this fax from the company with their report, you know, on your study. You may as well have it. And it had some interesting stuff, like there may have been no formal protocol for the study. It appears that the protocol as such was developed during the course of the study as information came to hand, which actually wasn't true because we'd actually applied to the Medical Research Council for money and been turned down. So that was the protocol. And then we started getting these reviews. This is the first one that we got. From Feinstein, who's sort of legendary. I shall be very surprised if the work is accepted by the Lancet. The editors of the Lancet, however, sometimes do not seek a careful external scientific peer review, and many editors nowadays are attracted by potential publicity for published reports. If the work is accepted and published, the devastating criticism and subsequent embarrassment for authors, editors, etc. will occur afterwards. That was the first review we got, and we got about 10 more. In similar vein, though this was maybe the strongest. And like I said, I just finished my postdoc, so I was fairly junior. The other guys knew nothing about epidemiology, so it's easy to be convinced by this stuff. But I knew they were crap, but it was kind of hard to explain that. And they also got the all the reviewers together. They met in the Ritz-Carlton in New York. Some of them flew on Concorde. They had a very nice time. They had another meeting in the Beverly Hills, Wilshire. If you've seen the film Pretty Woman, that's the hotel there. It's very nice. I've driven past it. And they all agreed that the study was rubbish. We got accepted. We will publish your paper on phenobarbital and asthma. We have reports from 2 referees who raised small points. I only found out a couple of years ago that the two referees, one was Geoffrey Rose and one was Ross Anderson, who are both very good epidemiologists in the UK. So we thought, well, you know, we're getting all these critical reviews, but the Lancet's accepted it. And then we heard these rumours that they might have changed their mind. And about 10 days later, seemed everyone else knew before us, but 10 days later we got the letter which said some of the Boehringer commentaries have now been sent to us and are causing us some anxiety. They offered us three options, either counter convincingly, basically withdrawal, counter convincingly the very critical comments, and they made clear they didn't think we could, or publication in the second half of the journal accompanied by a highly critical editorial, which is an option I've never heard of before. So we wrote back and basically said we're pissed off. We're concerned that our scientific paper was accepted unconditionally. We look forward to seeing it in print. And then we were never getting the proofs. It turned out they'd been sent by sea mail. Maybe it was just an administrative error, but it takes 3 months to send them to New Zealand by sea mail. But one of the other guys was over in London, so he went to the Lancet offices. They showed him the box of stuff from Boehringer, and he sat down and did the proofs. So it's coming out on 29th of April. On the 28th of April, the company got together this whole bunch of stuff, all the reviews, bunch of stuff that was a bit dubious, like graphs that had points in the wrong place, so it looked like the epidemic was going away when actually it wasn't. And they couriered a copy to every doctor, every pharmacist and every health reporter in the country the day before the paper came out. And also, they got these expert committees reported, even with no mention that they were funded by the company. Serious flaws in studies. This panel, experts from the US, Canada and Britain have attacked a New Zealand study saying it was seriously flawed. And, you know, we were in Wellington. Flight of the Conchords are from Wellington, if you know them, but not anyone else very famous is from Wellington. Well, Peter Jackson. But these were people from New York, you know, criticising what we were doing. And it was very influential. I checked out the idea that it might be confounding by severity, but it was pretty, and I did a bunch of analyses to try and check it out, but you know, I couldn't see any way it could explain it. But then I thought, well, it would be good if we did another study, and it would be good if we did a study that got round the main problem of the first study, which hardly anyone mentioned, which was that the information for the cases and controls was from different sources. So I actually left this graph on my wall for, 6 months. And the study we'd done, the deaths were 81 to 83, so it would be good to go back earlier. But how could we do that? You know, how could we go back and do a case control study of this earlier period and even get the information, but get it in a consistent way between the cases and controls? And I finally had an idea, and I actually, rang up the other guys quickly before I forgot it. And I got the idea by looking at this table from the first study. You can see we don't have to reproduce the whole study. We just need to reproduce this first line, because that's the severe group where the problems are happening. Now, what's happening in the first line is that you've got a case who died of asthma and almost always didn't make it to hospital, and you've got a control who was admitted at the same time and survived. But in the first, so that's the overall study, but the first line, the case had had an admission in the previous 12 months and the control had had an admission in the previous 12 months. And the thing is, it's almost impossible to get comparable information here because this person died and didn't make it to hospital and this person did. So you can't get comparable information unless you go back to here. And that actually makes a lot more sense, because if you think of the randomised trial you would like to do, you wouldn't randomise the acute medication on as the person's dying. You would actually get patients admitted to hospital, and when they left hospital, when they're discharged, you'd randomise them to have one drug or the other, and you'd follow them for the next year. And this is the observational study that corresponds to that. So you look at this previous admission and look at what medication the people were discharged on, and also, because it's all from hospital notes, it was all recorded at the time, it's as good a data as you can get, and you can do it blind. So I got all the relevant stuff from the hospital records, removed anything that might say whether the person had subsequently died, and mixed it up and gave it to the other guys and said, tell me what drugs these people were discharged on. So it was all done blind. So this was the second study. 58 deaths with a hospital admission in the previous 12 months, 227 controls who were a hospital admission but had had a previous admission. All the information was from hospital records. It was assessed blind. This is, so the phenotypal relative risk was 2, so that pretty much the same as before. This time, if you look at the more severe subgroups, it wasn't 13, but it was 10, which was pretty good. 11 out of 13 here on phenotypal on the most severe group. So for most people, it was this study that convinced them it was something real. We did another study where we removed this arrow because now you're just looking at people who were admitted to hospital and subsequently died, and other people who were admitted to hospital and didn't die. You're removing this restriction. As we expected, that actually gave slightly stronger relative risk because having the arrow here actually sort of indirectly controls for confounding by severity. So these are 3 studies. You know, the third one was the more recent time period. It wasn't as strong, but still very much in the same direction. There was a study done by the guy who chaired the Boehringer Committee in Saskatchewan. It was one of the first good studies in this area with electronic health records. Cohort study with nested case control analysis based on patients with 10 or more prescriptions for asthma drugs during a 10-year period, and then they were followed. If they had a death or they were chosen as a control, the asthma medication was assessed over the previous 2 years. There's a serious problem with the design, which I won't go into now because you've got to get to dinner, but I'll mention it in 10 seconds. Basically, someone could get into the study by having 10 prescriptions in 1978 and then recover and be completely asthma-free, but still be selected as a control in 1987. So basically all the cases were on asthma drugs. Something like 90% of all the cases were on asthma drugs. Something like 90% of the controls were on asthma drugs, but some of them were not because they no longer had asthma. Now that's okay if you're comparing within the beta agonists, but if you're saying take a beta agonist or not take a beta agonist, you get a big bias between the cases and controls. But if you analyse it the same way our study was analysed, they got an odds ratio for phenotypal of 5.3. So this was published in the New England Journal. You might think this was worth reporting. They didn't report it. I only found it out because I got leaked a draft copy of the paper. What they did was do a general analysis of any beta agonist, yes or no, and that suffered from this bias that some of the controls were not on beta agonists because they no longer had asthma. And what they concluded was that there was a general problem of beta agonists, and maybe phenotypal was a bit worse because it was a bigger dose, but if you halved the dose, then it looked the same as the others. So it actually got reported as showing that there was a class effect of beta agonists and that phenotypal was no different from the others if you adjusted for dose. The additional problem is that because they use logistic regression, it's an exponential dose response. So if you believe the curve and you take half the dose, you get 1/4 of the risk, which then makes phenotypal the same as the others. So we argued about this a lot. I was on, and then there was a Japanese study, which found the same thing. And that's the sum total of all the studies. I was on FDA, Food and Drug Administration panel in Washington, and it was brought home to me because, the Saskatchewan study had just come out and there was a big alarm and people said, well, we use a lot of beta agonists in the US. How come we're having no epidemic? Well, actually, phenotypal was never licensed in the US, so that might be why. But we'd sit and argue away. Actually, me and Walter Spitzer, who did the Saskatchewan study, were sitting next to each other, and overnight they moved our chairs, so we were opposite side of the table. But we'd argue away about selection bias and case control design, and I'd sort of quite a big audience, and I'd sort of got to know the drug company people, I'd got to know the respiratory society people. There was another group I didn't really know, and we'd stop for coffee and they would rush to the phone. This was the days before cell phones, so they'd have to find the nearest payphone. And I found out afterwards they were financial analysts working for stockbrokers, so the share prices were going up and down depending on who was winning the argument. Okay, so anyway, in New Zealand we won the argument, drug got restricted, that's the sales, that's the death rate. And now the death rate dropped by, actually the embarrassing thing is it dropped by more than it should have, but it dropped by 2/3 within, and actually this is the year that the study came out, and it came out mid-year. The first half of the year is there, and the second half of the year was there, so it dropped by half in a few months. So that was fairly conclusive for me, though people still argue about it. At the time, there was a few reporters who were keen on doing something. They never got around to it, so I sort of wrote it all out myself, not as a book, but just to get all the factual stuff straight, you know, while I remembered it. I thought it was, you know, normally, like if I'm angry with someone, I write a letter and put it aside for 24 hours. This I wrote the whole book and put it aside for 15 years. But eventually I got round to doing it and got published by Auckland University Press. It didn't actually sell many, but you know, it sold to epidemiologists and respiratory people, but it was supposed to be a popular science book, but never sold much. But it came out and I was quite pleased with it, and I got this email out of the blue from a woman who said, I think your daughter's alive, my daughter's alive because of you. And epidemiologists, you don't get that sort of thing very often. And she'd had severe asthma as a teenager during the epidemic, was ending up in hospital a lot, and had nearly died a few times. And the husband was at a meeting at Auckland Medical School or Auckland University, and got talking to Robert Beaglehole, who was one of the people on the periphery and some of the committees about this stuff. And the daughter was on phenodorol, and Robert said, well, there's research coming out in the next few months, I can't tell you about it, but get her taken off. And probably coincidence, but she got better. And then 15 years later I did the book, the mother got in touch with me, and she decided to commission this painting. So that's the mother, and the daughter, who is now 32 and had 2 young children. These are the other 3 guys I did the work with, and this was the Minister of Health. And it's just a dark picture of a bunch of inhalers, basically. But as far as I know, it's the only painting that's ever been commissioned to commemorate an epidemiological study. So the medical school that tried to stop us doing it and basically made our lives miserable, it's now up in the library with a nice little plaque claiming credit for it. Okay, so a couple of things to finish. What happened to phenodorol? It was never licensed in the US. New Zealand, Australia, Japan basically either banned it or restricted it so much that the sales dropped to less than 1%. The UK actually never did anything, though it was only 2 to 3% of the market. So they sort of seemed to think that didn't matter. Worldwide, they halved the dose and then said the problem's solved. And I don't think that's true. I think it's a fundamentally different drug. But if the dose is the problem, it was 4 times as big as it should have been, just like isoprenolone forte was 5 times. They only convinced themselves to halve the dose because they used this logistic exponential function. But they halved it and still sell it worldwide. I think there's quite a lot still being sold in Latin America. Doubt has been cast on the safety of all beta agonists, whether it's a class effect or whether it's just phenodorol. Some of you may have taken salmeterol or Severity. It's a long-acting beta agonist. That was coming out just when we'd done the research, and so in New Zealand it wasn't licensed for a long time. In the US they said before they would license it, they had to do a proper trial, which is the SMART study. And I'm actually not convinced there is a problem with Severity. It's long-acting, but the side effects are not the same. But anyway, they did the SMART study and did find an increased risk of death. But it all got explained away. And it got explained away the same way the original New Zealand one was. They said The problem is people were not taking their inhaled steroids, and if you take them with inhaled steroids, it's fine. So the recommendation was to only use it with inhaled steroids. The problem is, if you're on salbutamol, if your risk is here, if you're on phenoterol or something else that's up here, whatever level you're on, taking the inhaled steroids lowers your risk, but it doesn't actually lower it back down to being on salbutamol. So some of these other long-acting beta agonists may have a problem, but it's not completely clear. Many countries have experienced a gradual increase in asthma deaths since the 1960s. This may be due to a class effect of regular use of beta agonists, or may just be due to gradual increases in asthma prevalence, which we know has happened and is happening worldwide. These effects are difficult to identify in epidemiological studies and require clinical trials and other clinical studies. The epidemics are different. They've only happened in 6 countries in the 60s after the introduction of isoprenoline forte. They occurred again in New Zealand, and the epidemic actually lasted 13 years before we got involved, and started after the introduction of phenoterol. And most people don't agree with me, but I think it's a different drug. They're both high-dose, full agonists with relatively greater cardiac effects. Certainly no other beta agonists have caused mortality epidemics, although there are still some minor concerns about other long-acting beta agonists. And yeah, I think that's the end of the story. We can go to dinner in a moment, but any questions or comments? Yeah, that's it. Good, thanks for listening. It's dinner.